My name's Jonathan, and I work on the Mobile Ninjas. We're a team within Google passionate about testing and testability. If you've ever written tests for Android before, it's likely you've used some of our products, Espresso, Roboelectric, or the Android Testing Support Library. And together, these tools combine for billions of test invocations, both within and outside of Google. So today, there's a general consensus within the software development community of the virtues of writing tests. Sure, there's a cost to writing tests, but it's an accepted one, and it's one that quickly pays dividends throughout the life cycle of your project. Tests provide fast feedback on failures. Like a bug caught early on in development is far cheaper to fix than after you've deployed your application. They give you a safety net for making changes to your code. You're free to refactor, clean up, and optimize, safe in the knowledge that you're not going to break any of the existing functionality. And what's more, a suite of readable tests provides the living, breathing specification of your application's behavior. Now, in software development, there exists the concept of the testing pyramid. It's made up of 3 layers: unit, integration, and end-to-end tests. And as you go up the pyramid, you're gaining fidelity, but this comes at the expense of test execution time. It also gets harder to maintain and debug these kinds of tests. But just like a rock band, where you need a perfect blend of musicians to create that great track, each layer in the pyramid is equally important. You're leveraging the advantages of one layer to compensate for trade-offs in others, to produce a holistic, automated testing environment. We recommend a 70-20-10 split as a general healthy guideline. And now, while the rules of these pyramids still apply, some of the unique characteristics of Android development have introduced some difficulties along the way. So unit tests, due to their need to be fast, will run on the local workstation. And integration and end-to-end tests, due to their need to run in a really faithful environment, tend to run on a real or a virtual device. And so, separate tools have evolved at each layer of the pyramid. Roboelectric, or the mockable Android framework for your off-device unit tests. Espresso, and the Android Testing Support Library for those on-device tests. Now, Android's got some really familiar core concepts, such as getting a handle to your application context, or maybe driving your activity lifecycle. And each of these tools has its own distinct APIs and ways of doing things for achieving these exact same tasks. Now, this has led to something of a test writing crisis. As a developer, it's hard sometimes to know what tools are available for use and which of those are recommended. Having multiple tools at each level has led to an explosion of styles, each with their own distinct patterns and APIs. And this, in turn, leads to a lack of mobility between layers. Tests can't easily be refactored or reused between layers in the pyramid without being completely rewritten for a new tool. To discuss this further, let's orientate ourselves with what constitutes a well-structured test. So there's some following common patterns that define a well-structured test. And so we generally break tests down into 3 clear sections: given, when, and then. And I like to separate them with a blank line to clearly demarcate them. So given some predetermined state of the system, when you execute an action that you wish to test, then verify the new state of the system or some behavior has occurred. Be sure to name the test after both the condition you're testing and the expected outcome. Keep the test focused on very specific behavior, and then test all your behaviors independently. And less is always more with tests. These guidelines will help you keep each test understandable in isolation. Use common setup methods only for scaffolding. This is maybe creating the object that's under test and wiring up some of its dependencies. Let's take a look at the problem of the explosion of styles, and we'll highlight this using a simple test case. We'll have a single activity with one button that responds to a click, sending an intent to the Android system. And I'm going to walk you through this test case, comparing the different styles of Mockito, Roboelectric, or Espresso. So first up, let's consider Mockito. Now, mocking is a really powerful tool, but it's one that's often overused and sometimes used inappropriately. Mocking your own classes is great, but while mocking the Android framework may seem like a great idea at first, it can soon lead down a path of difficult problems. Many Android classes are stateful, or they have complex contracts, and these are really difficult or even impossible to satisfy with mocks. So even though we don't recommend it, let's just start by taking a look at one of these tests and walk through it using the Mockito framework to mock the Android framework. So in the given section, we can new up our activity under test. But look, we first of all have to stub out some of the Android framework behavior in the superclass activity so that it responds as we expect in our tests. Now, this introduces some problems. First of all, we're partially stubbing the class under test. And this means we're not testing the true behavior of that object under test. And furthermore, it brings with it excessive stubbing, which introduces all this undesirable boilerplate. And that quickly becomes distracting from the true intention of your test. For the when section of the test, to execute your code under test, you'd have first had to need to register an argument captor earlier to get a handle on that click listener, which you would then invoke manually to call the code that you're wishing to test. Now, with this approach, you can soon descend into an undesirable mess of argument captors, stubbing calls, and answer invocations. Finally, in the then section, to obtain intent sent to the Android system, you're going to have to use another argument captor. And mocking the Android frameworks in this way tends to force you into testing implementation details when you want to be testing behavior instead. And furthermore, these drawbacks have tended to lead to developers to build their own abstractions to isolate Android. This, in turn, leads to its own set of problems. Firstly, you're introducing another layer of cruft into your application. And secondly, you're introducing testing gaps where bugs can hide. And we believe that while you should architect your application very thoughtfully, the limitations of the tools shouldn't dictate your application architecture either. So let's see how this looks like with Roboelectric. Roboelectric is the popular open source testing framework that allows you to follow the best practices surrounding mocks, as you're able to use real Android objects in your tests rather than having to program your own stubbing behavior in each test. It runs on your local host, which means it's very fast, making it ideal for unit tests. Roboelectric tends to create tests that read a lot cleaner. So let's walk through each section in turn. In the given section, we can simply bring an activity into the resume state for our test just by calling Roboelectric's setup activity API. In the when section, we're able to use real Android SDK APIs, such as find view by ID, to get a hold of the view, and then Roboelectric's click on API, safely click on that view and invoke the code that we wish to test. And finally, in the then section, we again use Roboelectric's own testing APIs to check that the intent was sent to the system. See how much cleaner this version is. We're focusing on the items that really matter in the test, and we're free of all those extra pieces of distraction. Now, Espresso is a UI testing framework, and it runs on a real or a virtual device. It provides you with a really realistic environment. The trade-off here is a much slower execution speed. You're building up your entire APK, deploying it to the device, and instantiating the test run, waiting for the results, and then collecting those back on your local workstation. All of this is adding valuable development cycles. Now, the exact same Android concepts exist here. We're just getting hold of an activity, clicking a button, and then verifying an intent was sent to the Android system. Here, though, as you'll see, the APIs are very different. Let's step through this one together. So in the given section, we'll use the activity test rule, which comes from the Android testing support library. This can be used to start an activity, bring it to the resume state, and provide us with a handle to it in our tests. For the when section, we can use the espresso view matcher APIs. We'll find the view in question, and then safely click on it to invoke the code that we wish to test. And finally, in the then section, we'd use the espresso intents library to capture that intent and verify that it was the one that we wanted sent to the system. Notice here that while a test has many similar structures to roboelectric test, the example that we saw earlier, the syntax is very, very different. So, while each of these testing frameworks have contrasting strengths and weaknesses, it's this explosion of styles that's really become the big problem for writing tests. Who in the audience has been using roboelectric to write tests? Raise your hands. And what about espresso? And who's using both? OK, cool. We often hear developers talking about, I need to write a roboelectric test, or I need an espresso test. But we'd much rather you be thinking about writing an Android test instead. We feel as a developer that no matter what kind of test you're writing, you shouldn't first have to think about environments and tools and libraries that you'll need. We believe that you shouldn't have to suffer the mental load of having to learn multiple sets of APIs for doing exactly the same thing. So, and of course, you should have the freedom to refactor and reuse your code, no matter where you choose to run it. So what if there was only one set of APIs that you needed to learn? And now imagine also being free to focus on writing your test, rather than considering those tools and libraries and environments. Well, to make this a reality, today we're launching Android Test. It's part of Jetpack. With Jetpack, testing is now a first-class citizen of the Android toolchain. We're unifying the development experience around a canonical, high-quality set of APIs that will reduce the boilerplate and eliminate the number of tools that you need to learn. Naturally, Kotlin in support is included, allowing you to write beautifully concise tests. And of course, all of this will be open sourced. We love contributions from our community members. We're going to satisfy developers' needs in each of the 4 key sections of the test. Remember, scaffolding, given, when, and then. Scaffolding encompasses the configuration and control APIs. Think getting a hold of that application context. For your test scaffolding, Android JUnit Forerunner is used to execute your tests. You can use the instrumentation registry to get a handle to that application context. Well, today, we're excited to announce, for the very first time, you can now use these APIs for both your on- and off-device tests. The next section of a test is the given section. And here we're going to provide 2 key categories of APIs for you. Firstly, the Android JUnit rules from the Android testing support library will become part of Jetpack. And we'll be soon adding more APIs to help drive the component lifecycles for you in tests. As you've seen previously, the activity test rule is used to start up your activity and make it available to the test in the resume state. You've probably used this API running on a device many times before. Well, today, this API too will be available for tests that run off-device as well. Secondly, we'll be providing you with a set of Android test data builders. These will help you construct Android objects that your code under test will interact with. Many of the Android framework classes that you need to have for setting up your test state are difficult to create. Often there's no public constructor, so they can't be instantiated for test. Perhaps they're final, so mocking's out of the question either. And sometimes they're just plain clumsy to instantiate with any degree of brevity at all. So we're including Android test builders within Jetpack to give you a concise way to set up your test environment. They produce readable code. They're a fluent way to create the Android components that you need to interact with. And of course, they're portable. Android test data builders work for both your on and off device use cases. The third section of a well-structured test is the when section, exercising the code under test. Usually, this is just simply a case of calling your own code directly. But when you're writing a UI test, it's likely that you'd reach for the espresso view matcher APIs. Today, we're happy to announce that Espresso 2 is joining Android Test Jetpack. Espresso View APIs are fluent, and they read beautifully. You've used them for your on-device tests for a while now. And today, we're providing preliminary support for these tests in the off-device use case also. The final part of a well-structured test is the then section. This is where you make assertions on the state of the system in response to an action. So firstly, Espresso Intents 2 is going to be joining Jetpack as Android Test Intents. Those intents APIs that you've been using for your on-device testing, great news. Today, they too will run in your off-device tests. And finally, we're also releasing an assertions library to help reduce the boilerplate in your tests. Using traditional JUnit assertions can lead to tests that are not immediately readable. See here how easy it is to get the actual and the expected arguments mixed up. And Android uses a lot of integer constants for efficiency. But this makes it difficult to comprehend the error messages in tests. At Google, we love to use Truth. It's our own open source, fluent testing assertions library. Using a fluent assertions library is a great step to producing more readable code. And writing the test becomes much more easy too, because you can lean on the built-in support of your IDE's auto-completion feature. So to help you write concise tests against Android code, we'll be releasing a set of Truth extensions for Android, which reduces the boilerplate, reads beautifully, and gives immediately meaningful error messages. Of course, these assertions will work across all environments, both for your on and off-device tests. So, with Jetpack Android Test, we'll be bringing you the tools that you need so that you can concentrate on writing beautifully concise, easy-to-read tests without first worrying about libraries or tools or environments. A single set of canonical APIs for common tasks that will reduce the boilerplate, leaving your tests clear and readable, and that are environmentally agnostic, allowing you to run the tests either on-device, on your local workstation, or perhaps in a cloud test lab. And now that I've shown you how to use a unified set of APIs that decouple the act of actually writing a test from where it's going to run, I'll hand you over to my colleague Stefan, who's going to show you how you can run these tests in the new simplified world. Stefan.
Thank you, Jonathan. Welcome, everyone. 10 years Android, quite amazing. I also want to say a big welcome to everybody who is joining us at the live stream today. At Google, we believe that testing should be a fundamental part of your app development strategy. Let's bring back the pyramid. As we can see, our friend with the Jetpack has solved the API dilemma. Now that we got one API to rule them all, it's really easy to start writing tests for Android. No more excuses. We can start with a simple test for our business logic, usually a unit test. And over time, we can add more and more tests. Once we start implementing the UI for our application, it might be worth adding an integration test. This just became a fluent experience, since both layers support the same APIs. No more context switching. Great. But that's not the only use case where the new API become really handy. Let's imagine we have an integration test that got too large and complicated. I have seen many of those tests. It's just too convenient to test business logic and UI flow in one single test. At Google, we don't like those tests. They are hard to read, and they tend to become flaky. Small, well-focused tests are much better. So let's refactor this large, complicated test. Refactoring a large test can be a very painful task. Who in the audience has experienced this recently? Raise your hand. Here's some good news for you. If the original test was written with the new API, this task becomes much simpler. We still have to test our UI, and we'll keep this part in the integration test. This layer provides high fidelity, and we don't want to lose that for our UI tests. The rest, mainly business logic, can directly go into the unit test layer. Here, we gain speed, since we can run off-device on a local Java VM. So let's verify the refactoring together. We still have high fidelity for the UI test. That's good. We gain speed, even better. And the tests are decoupled and less complex. Nice job. Your coworkers will thank you. So let's run those tests. But wait, we still have to choose a runtime environment. It's not always trivial to pick the right one. We also have to work in multiple source sets. The combination of runtime environments plus source sets will lead to an explosion of test configurations. Just imagine how hard it will get to choose the right configuration. Should I run on a device or off a device? And don't we need to run the entire test suite on our continuous integration server before we submit? And you all know the feeling after we kicked off the test run, waiting eagerly for the results. Oh no, hold the submit. One of the tests is flaky. I'm pretty sure many of you have been in this situation. Flakiness is one of the biggest pain points for developer productivity. So what if there was a better way to set up your test harness, execute your tests in a reliable environment with unified test results? Today, we are proud to announce Project Nitrogen, the new single entry point for all Android tests. Nitrogen is fuel for your Jetpacks. With our expertise of running billions of tests a year, we had to build the fastest and most reliable test executor. Nitrogen covers the entire testing lifecycle, from setup to test execution and reporting. Nitrogen provides deterministic behavior across different build systems. It will be fully integrated in Android Studio. At Google, we already use Nitrogen to test our own apps, such as Gmail, Google Maps, Photos, YouTube, and many more. Nitrogen is highly extensible. It provides APIs for test authors to customize the test invocation at any point. Nitrogen will be fully open sourced later this year. But let me give you an overview. Starting with setup. Nitrogen connects your test to any execution environment, on device, off device, or in the cloud. It installs required test artifacts. And if necessary, it can run custom fixture scripts for you. Let me show you how this works. First, Nitrogen finds and provisions a device. This can either be a simulated device, a virtual device, or a real device. Once the device is ready, Nitrogen installs the application under test and the test. Nitrogen stages any test data dependencies and sets device properties. If additional setup is necessary, it can all be done here. Let me give you examples. Setting up a network tunnel, starting a hermetic server, granting permissions, and much more. And finally, it prepares the device for the next step, test execution. There are many ways how we can run an Android test. It's a little bit like running in the real world. Here we have sprints, mid-distance, and long-distance runs. We also have different environments: track running, road running, cross-country running, and mountain running. A unit test on your local workstation is like a sprint, as fast as possible to the finish line. The test suite on your continuous integration server is the marathon. The goal is to get to the finish line and not to fail along the way. Today, these tests are executed in different ways. From the command line, from Android Studio, or triggered automatically when you submit. With Project Nitrogen, this will become consistent. We provide a well-defined protocol and are unifying all the Android test offerings. Nitrogen uses our own device infrastructure to run your tests. Android Orchestrator and Android JUnit Runner. You can already enable the on-device infrastructure today. It has been available since Android Studio 3.0. The orchestrator collects your tests and kicks off test execution. By running each test in a separate process, shared state is minimized and crashes are isolated. Moreover, your tests are executed in a familiar JUnit environment provided by Android JUnit Runner. The orchestrator collects all test results, additional artifacts, and streams it back to Nitrogen. Nitrogen provides a unified reporting format for these test results. In addition, it provides a huge selection of test output data, such as logcat, screenshots, video, profiling data, battery performance, and much more. All artifacts are scoped per test. This means that, for example, a logcat snippet is reduced to the test method. No more digging through hundreds of lines of logcat. So let me show you how Nitrogen improves the entire testing flow on Android. First, Nitrogen finds a device and configures it for the test run. Second, it runs tests in isolation using the orchestrator. And finally, while tests are running, Nitrogen host-side infrastructure will be streaming the test results from the device, pulling down all test output data, and feeding it back to you. With Nitrogen, all this complexity is hidden from you. Whether you're running a test on Android Studio or on a CI server, Nitrogen is the single entry point for all Android tests. It works from a sprint to a marathon. Nitrogen can request a device in a Firebase test lab, reliably running your tests, returning unified test results. Nitrogen supports Google Cloud. From your workstation, you can deploy and run tests on a real device or on a virtual device. Nitrogen works seamlessly with Roboelectric. Now, we can treat Roboelectric as a simulated device. With Roboelectric 4.0, we have made big improvements in startup time and memory consumption. Roboelectric 4.0 is released today. And if this is not enough, Nitrogen supports your custom needs. For example, if you have an in-house device lab. Allow me to summarize. Previously, you had to learn multiple approaches for doing the same thing. Tools lack the mobility to move between the layers of the pyramid. You had to choose wisely. We have reduced the cognitive load by providing you a single set of APIs that work across environments for both on and off scenarios, and a single entry point for Android tests with the flexibility to customize any point in the test invocation. Jetpack with Nitrogen is a giant leap forward in test automation for Android. Write your test once, run it everywhere. This is just the beginning. Now, you have both the tools and the knowledge to accelerate your testing experience. I strongly encourage you to check out our code labs, especially our latest edition, Building Android Apps with Bazel. Bazel is the open source version of our internal build system, allowing you to build large Android apps at Google scale. If you have further questions, or if you would like to discuss your testing strategy, come find us tomorrow morning at 11 a.m. in the office hours tent in section A. We hope you enjoyed our session, and we would love to hear from you. So please take a moment to submit your feedback. And with that, happy testing.